Yeah, my talk will be about the metaphysics, two views of the metaphysics of relations, positionalism and antipositionalism, and I want to show that they are not really opposite views. And what I hope is that this will take away objections that some of you have against anti-positionalism. Here is the outline of what I'm going to do. First, I will briefly present the three views on relations, and I assume that all of you are familiar with them, so that can be done rather quickly. And then I'm going to say something more about positionalism and antiposition. We are going to zoom in on them. And then the next thing is I'm going to discuss how positionalism can be translated to antipositionalism, and how it can be done vice versa. And then afterwards, we will see that the two views can be united in a very nice way. And then I draw some conclusions. I start with the standard view on relations. Yeah, the standard view on relations, there the arguments come in a certain order. So take the state or the complex of the cat on the mat, then we have the relation on top of, where the cat comes first and then the mat in this complex, and we have the relation beneath, where the mat comes first and the cat second. So there was an order in the relata here. But the problem is that we don't see this order in the state itself. Another view is the positionalist view on relations. Here we have positions. For the state of the cat on the mat, we get a complex where the cat, we can assign the cat to the top position and the mat to the bottom position, and then we get a complex where the cat is on the mat. And there is no order between the positions. The last view I'm going to present here is the antipositionalist view on relations. And here the complexes of relation form a network interrelated by substitutions. So within the complexes themselves, there is no explicit order of the objects involved. It's just that we get a kind of, we have a mechanism for coordinating different complexes with each other. So for example, take the top one, when we have a dog being on a table, we can substitute a cat for the dog and a mat for the table, and then we get the complex of the cat being on the mat. And for the cat on the mat, we can make a similar substitution where we get a caterpillar on a mushroom. And we can go directly, of course, from the dog on the table to the caterpillar on the mushroom. So, like I said here, we get a network of complexes interrelated by substitutions. I'm not going to say more about the standard view. I think we all agree that that view does not give an adequate account of relations. And the reason is that at least for a certain class of relations, the arguments do not come in a specific linear order. I'm going to take first a look at positionalism. And I make a distinction between two different forms. And for lack of a better name, I call them thick positionalism and thin positionalism. First, I'm going to look at thick positionalism. In thick positionalism, assigning objects to positions result in relational complexes with objects occupying positions. So we assign objects to positions, and the result is what we see here on the right, a complex where the positions are part of the complex and the positions, they are occupied by objects. You could look at a position as a whole. It's also what Kit Fine said in Neutral Relations. He also made that comparison. Position is a whole in which something can be put. Yeah, there is a problem with thick positionalism, and in particular for strictly symmetric relations. And we are all familiar with symmetric relations, but there's a stronger notion of symmetry, and that's strict symmetry. Strictly symmetry, a relation is strictly symmetric if there is a non-identity permutation of the positions that has no effect on the complexes obtained. So switching objects in the assignments, that should result in the same complex. And if you have normal symmetry, now it's weaker, because for normal symmetry, you have something for every x and y. If you have r, x, y, if and only if you have r, y, x. So you can switch them, but it doesn't say that these complexes are the same. But strictly symmetric symmetry is an important notion. And thick positionalism gives two complexes for A's being adjacent to B, whereas for A's being adjacent to B is the same complex. We would like to have the same complex as B's being adjacent to A. And here we see the reason, because on the left, A, the position next is occupying A, and next is occupying B. And in the right complex, we have just the other, they are switched. Next is occupying B, and next is occupying A. So they cannot be the same complex. And this is a bad feature for thick positionalism. And it could be a good reason to throw positionalism completely away. But that's not what I'm going to do. We're going to look at another variant of positionalism, a variant of which I think solves the problem. Yeah, the variant I called thin positionalism, and in thin positionalism, you can substitute objects for positions. And the result is that you get a relational complex, not with positions in it, but only with occurrences of objects. And in a way, you could think of of a position here as an occurrence of a variable. Say if you have the expression or the formula 2 plus x equals 5, then you may substitute 3 for x, and then the result is that you get 2 plus 3 equals 5. And in that resulting complex, the variable itself doesn't occur anymore. And also here, you have positions assigning, you still assign objects to positions, but the result is not that you get, you still keep the positions in the complexes. You just have, you substitute an object for the position, and the result is, like I said here, an occurrence of an object. Yeah, I must say, I find this a very natural way of looking at positionalism. I don't see any good reason why positionalism would require that objects occupy positions. It's more or less taken, I have the idea taken for granted that it's that way, but I think there's no particular good reason for it. And now let's see how thin positionalism may solve the problem we had with thick positionalism for strictly symmetric relations. First, we substitute A for next and B for next. So we have here the positions next and next. And then we get the complex at the right with an occurrence of A and an occurrence of B. And we have, with the substitution, we have a corresponding mapping between the positions of the relation and the occurrences of the occurrences of the objects in the complex. Now substituting B for next and A for next results in exactly the same complex. It's just that the correspondence between the positions and the occurrences is switched. By no longer being changed by the rigidity of objects occupying positions, we have more freedom in the correspondence between positions and occurrences of objects in complexes. There is not necessarily a one-to-one correspondence between positions and occurrences of objects. In particular, we may allow a coalescence of occurrences. For example, for the love relation, we may allow that assigning Narcissus to the positions of lover as well as to the position of beloved results in a complex with only one occurrence. Just one occurrence of Narcissus. I do not say that this should be done, but it's a possibility. So that you might have very good reason for saying, when you have the love relation, then any complex has two occurrences that might be of the same object, but this is just a possibility to allow this coalescence. Yeah, it's certainly not a case that any picture of assignments of objects to positions represents a potential relation. There are certain restrictions, and an important restriction is the following composition principle. I said, and I give it only in a simplified form because it doesn't take occurrences into account. It just treats the objects in a complex. This is what it says. If you have two assignments, F and G, of objects to the positions of a relation, and they result in the same complex. So we have here F and G, and they result in the same complex psi. Then for any mapping H from objects to objects, the assignments F followed by G and G followed by H result in the same complex as well, or they both result in no complex. So in a natural way, you can compose mappings, assignments with mappings from objects to objects. As I said, this is in a simplified form because in the one that I presented in my paper, there I take the occurrences of the objects here into account, and then it looks more complicated, but basically the idea is given here. And the reason for mentioning this composition principle is that it is needed for a proper translation of thin positionalism to antipositionalism. Let's now take a closer look at antipositionalism. Yeah, as I said, a relation is a network of complexes interrelated by substitutions. Yeah, in a complex we may substitute objects for occurrences of objects, and this may result in another complex. And for each successful substitution, there is at least one corresponding surjective mapping of the occurrences of the objects in the first complex to the occurrences of objects in the resulting complex. So I assume that you substitute objects for occurrences of objects, but that after doing that, and when you get a resulting complex, then you also have a corresponding mapping of the occurrences of the first complex to the second, to the occurrences of objects in the second complex. Yeah, as an aside, I want to say something trivial, and that's that we can give meaningful names to occurrences of objects. And I think it's good to realize this, because it's sometimes thought that antipositionalism is essentially less expressive or less informative than positionalism. And in particular, when the network consists of only one complex. Sometimes it's thought that by having this complex, you have the network of complexes interrelated by substitution, that antipositionalism claims that from just that network, you can deduce anything that's important about that relation. And I think that's not the case, because you may have networks, for example, a network consisting just of one single complex, and just from that structure, not much can be said about a relation. But those relations, the complexes in those relations, they can also again be relata of other relations. And in that way, more can be said about the relation. Or we may say something in particular about certain occurrences of objects in a complex, when such a relation is so simple. For example, we may say of one of the occurrences, this is the agent and this is the patient, or we may talk about other roles. And as I said here, it's also possible to give good names to for occurrences. It's not, the naming is not part of the network itself, but it can be given in addition to it. Also for strictly symmetric relations, we get no duplication of complexes, just as in thin positionalism. For example, if we substitute B for the occurrence alpha and A for the occurrence beta, then we just get the same complex. And in red, I showed here the corresponding mapping of occurrences, the mapping of occurrences that corresponds with the substitution itself. Yeah, what I showed here on the left is a complex with two occurrences of the same object. And when you have this, you may also have different objects may be substituted for the occurrences of the same objects. and of the same object. And that's also a reason for working with occurrences, because we could also, otherwise we could just say we get a complex with objects in it. So don't talk about occurrences, but we like to talk about occurrences because we like to have multiple occurrences of the same object in certain complexes. And this makes it possible to make a more complete picture of the substitution possibilities. As in positionalism, also in antipositionalism, we can allow a coalescence of occurrences. Just that it's not necessary to do it, but it's a possibility. And one could, so one could allow that substituting the same object for distinct occurrences may result in the same occurrence. So if on the left we have Paris loving Elena, then, and we substitute for both of these occurrences Narcissus, then we may get a complex with just one occurrence, and that's an occurrence of Narcissus. Also for antipositionalism, we have a composition principle, and the idea is simple. A substitution followed by another substitution. So here we have substitution S, and here we have S prime. So S prime is followed, of S is followed by S prime. So a substitution followed by another substitution is the same as a single substitution with a straightforward functional composition of the first two substitutions. So here we have the composition, but it's here, I don't say S, here I don't write S dot S prime, because S is a mapping from occurrences to objects. And so I have to work with a corresponding mapping of occurrences to occurrences of objects. And here the composition principle is as you would expect, that you could, the way that you can combine and compose or compose substitutions. And again, here the reason for mentioning this composition principle, because it's important for the translations that we are going to take a look at now. First, we're going to look at translating positionalism to antipositionalism. And I start with translating positionalism to antipositionalism, and I treat thick positionalism and thin positionalism separately. First, I'm going to take a look at translating thick positionalism. And let's assume that you are a thick positionalist. Then you may simply form a network of interrelated complexes as follows. So let R be a relation that comes with positions P1 and P2. And let C be a complex obtained by assigning A to P1 and B to P2. So that's the one I have here on top. Then we could identify these pairs as the occurrences of the objects in Xi. And if Xi prime is the complex obtained by assigning C and D to P1 and P2, then we say that substituting C and D for alpha 1 for this occurrence, and so C substituting for this occurrence and D for this occurrence results in Xi prime. And here we can show the corresponding mapping we have between the occurrences. So this is the results that we would get. But there are a few problems. The first thing is that the translation is not adequate for strictly symmetric relations. And the reason is clear, because in thick positionalism, we can't deal with strictly symmetric relations at all. At least the way I presented it here. We could use equivalence classes of complexes to express strictly or strict symmetry. And that could be a good idea, but it feels perhaps a bit complicated. And there is also a complication in that not for every relation occurrences of objects can be defined in a non-arbitrary way in terms of fat theory and the basic notions of thin positionalism. And yeah, this is, for example, the case for a cyclic relation with R, A, B, C, D being the same complex as R, D, A, B, C. So here we can turn them and then we get the same complex. In particular, for the complex of R, A, B, A, B. So here we have R, A, B, A, B. It is not possible to define in a non-arbitrary way the occurrences in terms of set theory and the basic notions of thick positionalism. So we have here the picture on the left and on the right. It looks very much the same, but here we have beta 1 here and beta 2 here, and here they are just switched. And it's not possible to make a choice between them in a non-arbitrary way within set theory. And perhaps this should not be interpreted as a weakness of thick positionalism. It could rather be seen as a limitation of ordinary set theory as a modeling medium. Yeah. To prove this, and later in a few minutes, I will show a similar result. It's not trivial, I must say. It gave me some sleepless nights. Here in this picture, by the way, the donkey here at the bottom, the donkey at the bottom represents Bury Dan's ass. You can't make a choice between these two. For a thin positionalist, he may form a network of complexes as follows. So assume that you are a thin positionalist, and let again R be a relation that comes with a set of positions. Here we take P1 and P2. Then, without any judgment, the complexes of the relation can be conceived as the complexes in an antipositionalism. So the complexes are just, they stay the same. And we can define mappings, substitutions from one complex to another complex, and in the right way, because the composition principle of thin positionalism makes it possible to define substitutions between complexes, and it can be shown that the resulting network fulfills the composition principle of antipositionalism. So here the composition principles come into play. Yeah, two things should be noted. The translation does not yield a network if the positionalist relation has no complexes. So it might be possible to have a relation without any instantiation. That's possible within positionalism, but it's not possible in antipositionalism. We can't have an empty network. That's not a relation. Another thing to note is that the network obtained is not necessarily connected. So in this example, if we have here this relation, and we have get here a coalescence of occurrences, and here one, but they are not compatible with each other. If we have this, then there might not be a substitution between these complexes. It's not, perhaps it's not a big deal. It depends. If you are an antipositionalist who says, I only want networks in which all complexes are connected to each other, so that you have a connected network, then there are relations within thin positionalism that cannot be translated to antipositionalism. Now I'm going to take a look at translating antipositionalism to positionalism, and I will only look at translations to thin positionalism, because translations to thick positionalism are not really that interesting. And the idea is quite simple. An antipositionalist may form positions by subtracting objects from occurrences. You might say by substituting nothing for occurrences. Yeah, and in my view, the operation of subtracting is quite natural. In fact, it's very closely related to substitution, since subtracting an object from an occurrence might be seen as substituting nothing for the occurrence. And it is straightforward to check that the composition principle of thin positionalism holds for the reconstructed relation if the original relation satisfies the composition principle of antipositionalism. So the translation is in fact a proper one. Instead of talking about subtracting objects from occurrences, we might also talk about abstracting. An antiposition may form positions by abstracting from all individuating features of the objects of its occurrences. But I will, that's an alternative, but I will only talk here about subtracting objects from occurrences. Here we have two examples. For the love relation, by subtracting in the complex of Adam's loving Eve the objects from the occurrences, we get a positionalist relation with two positions, which I called here lover and beloved. But of course, with the translation itself, you do not get names for the positions. Similarly, for the adjacency relation, we get by subtracting in the complex of A's being next to B, a positionalist relation with two positions, which are called the next and next. Yeah, a key property for this subtraction process is that if the mappings between the occurrences corresponding with the substitutions are bijections, then the subtraction of objects from different complexes of the relation yields the same positions. So if I have here a complex and here another complex, and let's say that you can get this complex via substitution from this complex and vice versa, and then when you would subtract the object from the occurrences, then you just get the same positions. And the translation only works for relations with a complex from which all complexes of the relation can be obtained. And yeah, this is a real restriction, because it might be that there are antiposition relations which have more possibilities. For we might have relations with a variable number of objects in the complexes. For example, forming a circle, but where objects form a circle, but we don't say how many objects should be involved in it, then we have a relation with a variable number of objects, and that cannot be translated in a proper way to thin positionalism. At least I think it cannot be done, and not in the way I showed here the translation. And because of this, antipositionalism could perhaps be a richer theory than positionalism. Yeah, earlier I talked about the complication in defining occurrences for certain relations in an unambiguous way. And now we have a similar problem in defining positions. Since not for every strictly symmetric relation, positions can be defined in a non-arbitrary way in terms of set theory and the basic notions of anti-positionalism. And this is again the case for a cyclic relation. Only here we have a cyclic relation for which the complexes may be depicted as four objects equally spaced on a circle, and such that rotating them over 180 degrees give the same complex, but rotating them over 90 degrees gives a different complex. So only when you turn 180 degrees, then you get the same complex. For such a relation, we can't make a non-arbitrary choice for the positions. And in particular, we have here two possibilities, here on the left and on the right, where you see here we have P1, P2, P3, P4, and here we have P1 starting here, and then here we have P1, and P1 is over there. And again, burdens as cannot make a choice between these two. There's no non-arbitrary choice possible. And also this should not be interpreted as a weakness of antipositionalism, but rather as a limitation of ordinary set theory as a modeling medium. And whether there are other modeling mediums that do not have this problem is an interesting question, and I've no idea. A while ago I thought, oh, it may even be easy. You can make drawings where also for this problematic case, non-arbitrary choices can be made. But each picture that you make can also be expressed in an unambiguous way in set theory. But so that could not work. Hey, why can I? It works. I couldn't go to the next slide. Yeah, in this picture, I combined the translations between thin positionalism and antipositionalism. So first, we have thin positionalism, where we substitute objects for the positions And we saw that we can define a substitution between the complexes, and then as a result, you get an antipositionalist relation. And from the antipositionalist relation, you can go back to thin positionalism. You can construct positions by subtracting the objects from the occurrences. So here we have one picture with things, all things together. Yeah, some conclusions. I think thin positionalism and antipositionalism could be said to be two sides of the same coin. Their complexes are similar and they both make use of substitutions. And what's most important, they are translatable into each other in a very natural way. Yeah, and it should be said that antipositionalism is less demanding with respect to ontological commitments. In thin positionalism, a relation is a universal, and it's not only in thin position, but in positionalism in general. And positions belong, as also Kit said in his paper, Neutral Relations, belong to the fundamental furniture of the world. Whereas in antipositionalism, no ontological commitment to relations as universals and positions is needed. Yeah, and that's a nice thing of antipositionalism. And furthermore, we could say that in antipositionalism, as we saw, we may have relations with variable polyadicity, like forming a circle with a variable number of objects for which there is no equivalent positional relation. So, because of that, one may regard antipositionalism as the preferred view. But it's not, if you would make this choice, it's not a complete win, because there may perhaps be a reason for not jumping to this conclusion. Because positionalists, as opposed to antipositionalists, may talk about properties of relations that have no complexes, so no instantiations. And my final conclusion is that the name antipositionalism is misleading, because it's not really so different. It doesn't use positions, but since it can create positions in a very natural way, I think it's perhaps better to call it apositionalism. Well, that's it. That's what I wanted to tell about how positionalism and antipositionalism can be reconciled.